This will be the third video under implicit differentiation. So I have shown you various types of implicit function and how it differentiated, so that in this video you will assume it as exercises, so for you to try before you look at my video. So this is an implicit function, right? So as you know, the implicit function cannot write y in terms of x, so we cannot write y equals to fx, means y in the explicit function of x. So alright, then we're going to differentiate this one implicitly, right? But before we differentiate implicitly, especially this case have a ln here, right? Ln. So you know that ln, before you differentiate, you have to make sure you simplify the ln first, so it becomes easier for you, right? Make use of the knowledge of rule of logarithm. So xy to the power 1 or 2, as you know that, right? Square root. So you have exy as this one, nothing can do. So this one you have 1 over 2, alright, first step, you simplify. So you have xy equals to ex plus y. So I want to apply a white chain rule when I differentiate this one. So 1 over 2, so I bring it down, right? Because this is a ln, right? And further that, this one can be further break down. Can be further break down to ln x plus ln y. Why I can doing this? Because based on the logarithm law, the rule of logarithm, if multiply, this is a logarithm, so ln x multiplied y, a function multiplied with another function, I can rewrite as ln x plus with ln y. So starting from this line, I start differentiate with respect to x. I start differentiate with respect to x. So it will be easier to differentiate. Alright, let's start differentiating this. So differentiate. So this is everything bracket with 2 here. So I have write 1 over 2, right? 1 over 2. So differentiate ln x. Differentiate ln x at first. So ln x is 1 over x. Differentiate ln y. It's just like differentiate ln x. 1 over y. Just you need to add a dy dx. So equals to, so you have differentiate the left hand side here, right? 1 over x, 1 over y, dy, dx. So now I'm differentiating the right hand side. So differentiate exponent, the rule will be, you copy back the exponential, right? The exponent, the function. So then you're differentiating the power, right? Differentiate the power. Differentiate x, 1. Differentiate y, dy, dx. Now you can see that you have easily complete your implicit differentiation. So now it's like you need to rearrange everything. Alright, I can bring the 2 over here, 1 over 2, 1 over 2. I can bring to the right hand side. So the 1 over 2 here is multiplied with everything, right? So you bring over here, become 2ex plus y, right? So, but there is a x and y here. There is a fraction, 1 over x, 1 over y. So I'm going to multiply the whole equation, everything here. So the right hand side, the left hand side by xy. And for the other side here, the right hand side also multiply with xy to get rid of 1 over x and 1 over y. So as you see that xy multiply with 1 over x, so you can cancel out. You can see that, right? 1 over x multiply xy. So you have y, right? Y. So, and 1 over y multiply with xy. Xy in this one. You have x dy dx. So you already, there are no more fraction here, right? So here also you multiply xy. So you multiply xy here, you have 2 xy e x plus y, right? 2 xy e x plus y. So 1 plus with dy dx. Okay, after you solve this problem now, you expand this into the bracket. So you have y plus with x dy dx and 2xy ex plus y, 1 plus with 2xy e x plus y dy dx. So now you have reached this step. So it's a time for you to group the dy dx together, right? It's no, any methods as long as the dy dx is grouping together. So I'm bringing this one to here. So it means that I have 2xy ex plus y, right? 2xy ex plus y dy dx. This is minus x. Can you imagine that this whole thing is minus x dy dx, right? You bring to the other side. You bring this one to the other side here. So you have minus x dy dx. So you can write as minus x dy dx. You factorize the dy dx together. Because this you have dy dx, this one also you have dy dx, right? So as you minus here, minus x dy dx, you can factor out the dy dx, then you have all this. And this one without the dy dx, I'm going to move forward to that side. So become y minus with 2xy e x plus y, right? E x plus y. So this one and this one on the left hand side, and this on the right hand side. So then I know that my dy dx, finally I can conclude that my dy dx is, I taking this, alright. If you want, you can factorize the y. As you see here, you have common factor of y. If you want, if you don't want, is okay. So y, then you have 1 minus 2x e x plus y divided whole thing by, okay, if you look at this, you divide, right? You take this, divide by this one. So there is a x here, right? So I can factorize the x here. So if I factorize the x here, I have 2xy, sorry, as I already factorized the x, so I have 2y e x plus y, 2y e x plus y minus with 1. So this will be your dy dx for this implicit function here. Alright, hope you understand. I give you one more example. Alright, this will be the last examples for this video. So you have, this is an implicit function. Directly you can see that because it's very hard to separate the y and the x. So, or you can, or very hard for you to write, it's not easy for you to write y in terms of x. So this is an implicit function. So I'm going to differentiate this one implicitly. So by applying chain rule, so actually we are applying chain rule. So we differentiate the function with respect to x, right? So of course this is the angle, there no power here, right? So this is the angle inside the sine here. So differentiate this whole thing with respect to x means differentiating sine theta, for example, you are getting cos, right? And you write back the angle. And separately, you have to multiply, you have to differentiate the angles inside the angle function here. So you have 2x, different x squared 2x, differentiate y squared also 2y, but you need to add a dy dx. So whereas for the right hand side, we have uv, right? It's a product. You can see clearly that this is a product between a 3x and a function y, right? So I'm going to apply product rule. So product rule will be u v prime v u prime. So u 3x v prime differentiate y dy dx plus with v, right? V, so it's with y differentiate u prime, so you have 3. Then you have a complete differentiate. So this is a very important step here. So now it's just arranging, right? Arranging to get your dy dx. So as you need to expand this one over inside, so you have 2x cos x to the power of 2 plus y to the power of 2, right? 2x cos x squared plus y squared plus with 2y cos x squared plus y squared dy dx, right? So expanded this one and expand this whole thing. So alright, so now I have 3x dy dx plus with 3y. Alright, now I'm going to rearrange this whole thing. So with this term, put a star here, you have dy dx, and this one also you have dy dx. So if I rewrite here, I was getting 2y cos x to the power of 2 plus y to the power of 2, right? Cos x square y square dy dx, dy dx, plus, move over here, you have negative, right? You move across the equal, so you have 3x dy dx, right? Dy dx, and you have 3y here, and this is the term that without the dy dx, right? So I bring over that side, so it will be minus with 2x cos x square plus with y square, right? So this all as considered as 1 without the dy dx, and this one you have dy dx, you have dy dx, so you can factor out the dy dx, right? You can factorize the dy dx, and you still have 2y cos x square plus y square. Taken out dy dx, then you have minus 3x equals to this side here, you have 3y minus 2 cos 2x cos x square plus y square, then complete. Now your dy dx, you can state your dy dx now as you take everything here, 3y minus 2x cos x square plus y square divided by this one, right? It's a product between dy dx and this whole thing. So bring over there, you will divide, so become 2y divided by 2y cos x square plus y square minus with 3x, and this will be your answer, the dy dx for this implicit differentiation here. So I have shown you 6 examples, so hope you go through all the examples and try all the question. So now I'm going to discuss a different type of question is also involving implicit differentiation.